Professor C.K. Raju, welcome to the podcast. It's truly an honor to finally have you on the podcast. Welcome.
Thank you.
So there is so much we can discuss with you. We can discuss mathematics, science, physics, computer science, time. But today we're going to focus on mainly the calendar system, Indian and Western, and we're going to talk a little bit about mathematics as well.
Okay.
So let us begin with the topic of the Indian calendar system and why the Indian calendar is good. It's superior in terms of not just the science, but also from the perspective of economics and predicting the Indian monsoon, on which the economy largely depends.
Well, I think we need to start with the other end because as the tradition goes in India, you start with the Purva Paksh.
Okay.
So we start with what is wrong with the Gregorian calendar.
Okay, sir.
Now it is called Gregorian calendar, but primarily it is a religious calendar. And Gregory himself was a pope.
A pope.
Now, why should a pope be bothered to correct it? Because obviously he had to correct the date of Easter. It was related to the date of Easter.
Easter.
Okay. And that is why it was adopted. The earlier Julian calendar was adopted as the Christian calendar, as the official Christian calendar in the First Council of Nicaea.
Okay.
So, First Ecumenical Council. So, that was around 325 CE.
Okay.
And it actually practically defines the Nicene Creed. It defines Christianity.
Okay.
And the sole agenda on the meeting was to decide the date of Easter.
Okay.
Because the church wanted to unite Christians by having them celebrate Easter on a common day.
Okay.
Otherwise, they were following the Jewish festival of Passover, Pascha.
Okay.
Which is similar to Eid. Very similar. You sacrifice a lamb and so on.
I see.
So, church wanted them to be out of the control of Jews, the Sanhedrin of the council.
I see.
And it wanted to have it on a Sunday, on the Christian holy day, and so on and so forth. So, that was the thing with the Council of Nicaea.
Okay.
Now, the point is that if you are looking at this is a political move, but the correct name for it, instead of calling it Gregorian calendar, that makes it sound, very innocuous. We need to call it the Roman Christian calendar.
Okay.
It was the Roman calendar earlier. That is in the Roman Empire. It was the Julian calendar. It was adopted as the Christian calendar. And then it was reformed because it was a hopelessly bad calendar, even by the standards of its times. Okay, so now if you call it Roman Christian calendar, I think that makes many things clear. You see, let me tell you a little story.
Yeah.
When I was a child, a pretty small child, maybe 5 years or 4 or 5 years or something like that.
Yes.
I started learning about the calendar. And so I wondered. I said, look, this calendar, I can tell when our Republic Day is coming. I can tell when our Independence Day is coming. But I can't tell when Holi is coming. I can't tell when Diwali is coming.
Yes.
So why is that? So I asked my mother. And my mother, she was an educated person. She was a principal of a college, of a postgraduate college. And she was teaching, but she was colonially educated.
Yeah.
This was in the 50s.
Okay.
So the British had just left. And so the colonial influence was very strong.
Okay.
So what she told me was, you see, this is a secular calendar.
Secular calendar.
It's a secular calendar, and therefore our Independence Day and Republic Day, they are secular festivals.
Okay.
And therefore they come on a fixed day on the secular calendar. Holi, Diwali, etc., they are Hindu festivals. So they are movable on that. So that is a different calendar.
Okay.
So of course I was not satisfied. I said, what about Christmas? Christmas comes on a fixed day. She had no answer to that.
Okay.
So the point is I was not satisfied. But the point I'm making is that unless we call it by its proper name, people get confused that it is a secular calendar.
Okay.
And all our secular historians use it.
Yes.
Now, it is a bit of a shame that our two secular festivals are defined only on the Christian calendar. Why is that? I mean, people talk of secularism and so on. So if you're talking of secularism, then you need to change it to a secular calendar. Why is there no noise about it? And all of our secular historians, they use that calendar. And the point is, every date on that calendar is given in terms of AD or BC.
Yes.
Now, what is this AD? Anno Domini, the year of our dominator, Lord.
Yes.
So why should I admit that the Christian deity is my dominator? I don't want to admit that, but they have no problem, secular historians, saying AD or BC.
But nowadays they're trying to mask it with CE and BCE.
No, this CE is very wrong because they call it common era. It's a common deity. It's not a common deity.
It is not.
See, if you call it Christian era, that would make sense. But they call it common era. It's not a common deity. It's just a mask. It's another mask that is there.
Yes.
Right? So it should not be called, it can be called CE, but CE as in Christian era, not as in common era.
Yes.
All right. It's not a common mode of worship. So that's the point that I'm making, that if we accept this nonsense about AD and BC, or even if you say common era and so on, that everybody, what is common about the birth of Jesus? I don't even recognize it as a historical event. It is silly to say that it happened in the year 0 or the year 1.
Yeah.
Because the calendar which we have, this calendar, the date of Easter, because it was slipping. It was a bad calendar.
Okay.
And it slipped immediately within a century after the Council of Nicaea.
Okay.
It was wrong in the second decimal place, and therefore it slipped in 100 years. They tried to reform it. But eventually it was in the 6th century, Dionysius Exiguus, Dionysius the Little, he reformed it. And he back calculated the cycles of Easter. And on that basis, he came to year of our Lord.
Okay.
And then later on, they did not know what to say for dates before that, so they said before Christ.
Okay.
Right? So this has nothing to do with any historicity, of being recorded that this was the time when Jesus was born. It was a calendar which was fixed in the 6th century.
Okay.
So, point is that it is not related to any historical event, but all our history is done in terms of that. It's not a secular thing, and nobody has any problems with, no secular historian of the Romula Thapar type has any objection to it. That is what is troubling.
Okay.
So, I think if you call it Roman Christian calendar, at least gets the correct things, and you don't have to recite these superstitious beliefs in AD and BC. Now, see, it's mischievous. Let me explain why it is mischievous.
Yeah.
When the Christian missionaries first came to India, they realized that India is militarily too strong. Mughal power at that time was much too strong for them. So they tried to convert India by the strategy with which they captured the Roman Empire.
Okay.
By conversion. So, Akbar, he had his Deen-e-Ilahi and he had his Ibadat Khana, and so he invited people of all religions.
Yes.
He invited them also.
Okay.
Now they said, we have got this golden opportunity to convert the emperor. Once we convert the emperor, we'll have all of India in our hands. And they announced it as that, this Montserrat. So the 3 Jesuits from Goa came to Akbar. And they spent a lot of time there trying to convert him. Of course, he was not converted because Ibadat Khana means he asked questions. What is this virgin birth? I don't understand.
Right, yes.
So they had no answer. They said, you have to have faith.
Okay.
But then they started teaching because they failed with him. They had this Constantine strategy. They could not convert Constantine, so they converted his son. So they started teaching Akbar's grandson. The first lesson they taught him, it is on record in that commentary. So, first lesson was take the name of our Lord.
Okay.
So, if you take the name of the Lord, in reciting every date, you have at least partly fulfilled that purpose. So, it's something mischievous that in our teaching today, first thing we teach a child is the date of birth, and that date of birth is linked to a belief, an articulation that Christ was born, that Jesus was there, He's a Lord, and so on and so forth. You have to articulate it, that's a superstition.
Okay.
Why should we articulate it? Okay. So I think that is the thing that, the other thing is that it lacks, it's unscientific.
Unscientific.
It's completely unscientific.
Okay.
It's a religious calendar.
Okay.
It promotes superstitions and it is unscientific.
How is it unscientific?
Very simple. Look at the months. So months are 28 days, 29 days, 30 days, 31 days. Now how did this nonsense come about? Just think of it. month, see, calendar is supposed to relate to some natural cycles.
Cycles.
Right?
Yes.
So you have the annual cycle of the sun, that's a year. You have the cycle of the moon, that is the month.
Yes.
Now, how can 28 days, 29 days, 30 days, 31 days? It has nothing to do with it. So actually, if you see, the Romans had a very bad calendar. And it was only after they conquered Egypt, Egyptians gave them this calendar.
Okay.
And so Egyptians gave them a reasonably systematic calendar. And of course, it was named Julian calendar after Julius, but Romans did not even understand it.
So they imported the Egyptian calendar?
No, they made a special calendar for them.
Okay.
For the Romans.
The Egyptians made a special calendar for the Romans?
Yes,
okay.
They made a special calendar for them.
Okay.
That was the Julian calendar.
Okay.
And the speciality of that calendar was that it did not have fractions.
Okay.
So the year was 365 and a quarter days at that time, roughly. That is a bad figure, but that was the figure they had. Because that's a simple figure which Romans could understand. So they said every fourth year is a leap year.
Okay.
And Romans could not understand that. 20 years they could not understand that. You see, that is proof that they got the calendar from a foreign source. Their own calendar was awfully bad. Because to convert from the old calendar to the Julian calendar, it took them a year of 445 days.
Okay.
So it was so awfully bad. Right?
Okay.
So that is the situation. Then Augustus Caesar, in his time, 20 years after Julius, he understood this point about every fourth year because they were counting every third year. So let us say 2020, so you take that as current year, 1, then 21, take that as 2, 23, 21, 22, take that as 3, and 23, take that as 4. So 23 became the fourth year. So every third year they were taking as the leap year.
Okay.
And this mistake was corrected after 20 years.
Okay.
And so Augustus Caesar, who corrected it, said, well, month should be named after me also. Why only after Julius? July. So August was named after.
Okay, July, August.
Yes. And then, of course, he said that, well, I am no less a Caesar than Julius. So August should have 31 days. So it was decided purely on the basis of the vanities of emperors.
Okay.
Right? Superstition is one thing, vanities of emperors, that's how the Romans decided.
And it's still continuing today.
It is still continuing.
Wow.
And we are accepting it. And we talk of scientific temper. But when it comes to the calendar, which is very much in use right now, we never talk of science. Right? So I think that is two problems with it. The religious calendar, it is adopted by the Christian Church to determine the date of Easter. And it is a Roman calendar, so it is unscientific. So it's unscientific, not secular. I think these are the 2 points I would like to make. And it encourages superstitions.
Now, because it's unscientific, does it create any problems in today's world?
Of course it creates.
What problems?
Of course, I'll come to that. One simple problem is that equinox does not come on the same day.
Okay.
See, why did Gregory correct the calendar? All right. So, one of the problems was that because the duration of the year was wrong. Duration of the year, of the tropical year, is not 365 and 1/4 day. It is 365.242 days.
What are the two kinds of years?
A tropical year and sidereal year, there are many kinds.
Okay.
But two at least are tropical year and sidereal year.
Right.
So in India, for example, the sidereal year was used. So sidereal year is the time period in which the earth rotates around the sun.
One revolution.
So the sun comes back to the same position relative to the stars.
Okay.
Tropical year is the time from equinox to equinox.
Okay.
All right. And now why was this needed? It was needed because why was the Gregorian reform done? Because equinox was not clear. It had slipped by 11 days.
10 days.
10 days, 11 days, whatever the Gregorian reform.
That's a significant slip.
That's a very significant slip because if you're trying to determine the your latitude in daytime, you cannot determine it by observing the height of the or the angular elevation of the sun at noon. You can't do that because you will be off by about as much as 3-4 degrees. So that is not acceptable. And therefore, you need to have a precise date for equinox. Now, what you have is with all these different months and so on, you do not have a precise equinoctial year. Even now, after the Gregorian reform, you don't have. Before that, you did not have. Even after the reform, because it took a wrong figure of 365.241 days.
Okay.
And so it said that every fourth year is a leap year, except every 100th year, which is not a leap year,
Okay.
except every 1000th year, which is a leap year, right? Because they could not say 365.241 in a way which common people would understand, right? So this was the issue. And even now, because it is done not using precise fractions, but using leap years, it is true only on a 1000-year average. So equinox does not come on the same day each year. It goes on shifting a bit,
Okay.
right? And this is something which was known, for example, to the Maya. So if you see the Chichen Itza pyramid,
Okay.
a beautiful pyramid, and it has got stairs. At the bottom of the stairs, there are 2 stone serpents which are carved. On the date of equinox, the shadows come down. From down, wavy shadow comes down right up to the bottom. So it looks like 2 snakes have suddenly appeared.
Okay.
Right? And it's a beautiful architectural depiction of equinox which you can observe. So this is a very basic scientific thing which is not there.
Okay.
And so this creates a problem. If you want to know the date of equinox, you have to consult a manual. You can't just determine it from off the calendar.
Okay.
Right? So anyway, we have this unscientific calendar, and so I just want to summarize. We should call it the Roman Christian calendar.
Yes.
We should accept that it is unscientific. It is not, I mean, if you talk of scientific temple, let's take that as the first example. We should accept that it is not secular, it's a Christian calendar. So let us take these 3 points. Now let's come to the Indian calendar.
Okay.
So I think the Indian calendar, first thing I would like to state is, most people call it the Hindu calendar. Right? Now this is wrong. Why is it wrong? It is wrong for a very number of reasons. First of all, by calling it a Hindu calendar, you are suggesting it's a religious calendar, not a scientific calendar. Now I would like to say it is a scientific calendar, not a religious calendar. Now, before I come to that, the obvious thing, let us see. Obvious thing is Buddhists use it, Jains use it, you have Buddha Purnima, Jains use it, you have Mahavir Jayanti, you have Sikhs use it, you have Guru Nanak Jayanti.
Indeed.
All right. And this calendar went abroad. So Buddhists took it to China. Now, if it was just a Hindu calendar, why would they accept it? It went to Arabs. Indian astronomy went to Arabs. It's well known Sindh tradition. So if it was just a religious calendar, why would they accept it? So it was not just a religious calendar, and calling it a Hindu calendar denigrates the scientific nature of the calendar. It is used for Hindu festivals, it's used for other festivals also.
Okay.
Right? So it's a calendar. And this point is, it deliberately to denigrate. They won't call their own calendar a religious calendar when it is a religious calendar. So there was no official council which said a calendar is the Hindu calendar. And when the calendar reform committee sat down, said there are 5,000 different calendars.
Okay.
So there is no such uniformity, but still you arrive at the similar dates because of science. All right, let me give, well, we talked of Chichen Itza, let me also give this thing for Maya.
Okay.
See, the calendar, starting point of the calendar, the Kali Yuga, we say it is mythical. So the Kali Yuga is there in the Surya Siddhant. It is there in the Puran, also in the Surya Siddhant. And there it comes as Kali Ahargan. Okay. So you are counting the number of days from the Kali Yuga.
Okay.
Now this Kali Yuga is there is a scientific model there. We are saying that all the planets were in some particular position. So Rahu and Ketu was here, this was there, this planet was there, and so on. So some configuration you have. I'm not saying it was very perfect science or anything, but all science is fallible. By that standards, it was good science. And the fact that it was science is clear from the fact that the Maya calendar also begins at about the same time. So Kali Yuga begins at -3102, Maya calendar begins at -3114.
I see.
Yeah.
Okay.
So difference of 10 years in 5,000 years is nothing.
Okay.
This kind of dispute, this kind of difference of calculation always arises. So point is, this was a scientific model. Similar scientific models were in use across the world. Whether there was any connection between India and Maya is separate.
It's a different model. Yeah.
It's a separate story.
Yes.
These models were there. It was a scientific model which was in use. We won't admit that, just as we won't admit that this is a religious thing where you're talking about entity, Jesus, whose historicity you don't know. Here, this is a scientific model. So anyway, we strayed. Let us start with the, let me go to the question of months. First thing is, let us take the month.
Okay.
We saw that the months are very unscientific on the Roman Christian calendar because they are based on the vanities of emperors, Augustus and Julius.
Yes.
So the month in the Indian calendar is always 30 tithis exactly.
Okay.
Neither more nor less.
Okay.
Why? Because it is scientifically defined.
Hmm.
Scientifically defined as a tithi is the time in which the moon goes ahead of the sun by 12 degrees.
By 12 degrees.
12 degrees. So 12 into 30 is 360.
Mm-hmm.
So this is measuring the cycle of the moon, one particular cycle of the moon. We'll talk about it. So we are looking at what is called the synodic month or the cycle of lunar phases.
Okay.
So when do you have Amavasya? When the sun and moon are on the same side.
Mm-hmm.
When do you have Purnima? When the sun and moon are on opposite sides.
Yes.
Right?
Mm-hmm.
So 360 degrees, it will come back to whatever position it was. So Amavasya to Amavasya, Purnima to Purnima, whichever thing you start counting with,
yes.
Tithi will give you the complete cycle of phases. Of course, there's another type of month you can have, which is the Nakshatra Mas.
Okay.
This is the Chandra Mas, as it is called. You have, Chaitra, Basak, Jyeshta, Sad. So these are, this is Chandra Mas.
Okay.
The Nakshatra Mas is based on the Nakshatra.
Mm-hmm.
So there are 27 Nakshatras. So that is based on the time it takes for the moon to go around the earth. So a month, as I said, is always 30 tithis.
Mm-hmm.
Now 30 tithis is not 30 civil days.
Mm-hmm.
A civil day is the time, or Savan Din as it is called, is the time from sunrise to sunrise, or from noon to noon. Okay, but it is not the same thing as a tithi. Tithi is the relative movement of the sun, moon and the sun. So when the moon has gone ahead by 12 degrees, you say tithi has changed.
Okay.
All right. So 30 tithis will make a month, not 30 days. This confusion between tithis and civil days goes back to Greek times, early Greek times of Solon.
Okay.
Solon was a learned man before Plato and so on, and the first Lydian king of Greece. So as you know, Lydia conquered Greece, Croesus, and he is telling him that the year is 375 days.
Okay. Okay.
Because he's confounded these issues of what is a tithi and what is a civil day. He knew only a civil day. So people get confused by it, this notion of tithi, because it's a mathematical notion. They also don't know how to measure the angle between the sun and the moon.
Okay.
Right? Because it's not a trivial matter, first of all, how to measure an angle in space. What they teach you is only a protractor which allows you to measure angles on paper. How do you measure an angle in space? You need a sextant. And you can't use a hack sextant because you may want precise angles. Okay. So anyway, so tithi is a scientific concept. Month is always 30 days, Chandramas, all right? And this is, people say, you see, the point is, why do you have Adhik Mas and Kshay Mas? They're not intercalary months. They are part of the calendar.
Okay.
Part of the calendar because you are reconciling the lunar and solar cycles. It's not just based on the solar cycle. It's not two cycles. Obviously, these objects are there in the sky, which you are taking. You have to take both the motion into account, which they could not. See, why they could not? The very fact, the name for it is synodic month. Why is it synodic month? A synod is a religious gathering.
Okay.
Right? And religious gathering had to declare that this is the first day of the month. So calend is the first day of the month. So it has to be declared by the religious gathering or by some authority.
Okay.
That's why they are called calends. So, for example, the Jewish authority Sanhedrin, they declared. And you still see that practice because the same festival of Pascha or Easter continues into Eid.
Okay.
And in Eid, you see, Eid ka Chand, the priest has to declare that the moon has been sighted.
Okay.
So you have actually got a crescent moon there. And why have this declaration by a priest? Why not simply calculate it? Because they didn't know how to calculate it.
Okay.
But we have this very elegant concept of a tithi, which helps you to calculate it. Of course, you have to convert tithi into civil days and so on. That's a complex calculation. But the point is, this clearly gives you what a so-called synodic month is. Why should you call it synodic? Why does it need a religious gathering? It does not need a religious gathering. Okay, but I don't know any other term for it in English. You can call it lunar month, but you can have different types of lunar months, so that's ambiguous.
Yeah.
So it's called synodic month. All right. So you have this, and that is a scientific thing which was not there in the West. They had only the synodic month. Let me go to the next issue of seasons.
Okay, seasons.
Seasons, that's very important. because if you look at what Saha did, Meghnad Saha, he was the chairman of the Calendar Reform Committee.
Okay.
Appointed by Nehru.
Okay.
And he said, obviously the calendar is wrong. Indian calendar. Why is it wrong? It's wrong because it is using the sidereal year, whereas the seasons are decided by the tropical year. Now, tropical year is time from equinox to equinox.
Okay.
Now, what that decides is the position of the sun in the sky. That can decide the heat balance. He was a man of heat. He wrote a book on heat and thermodynamics.
Okay.
But if you are in England or if you are in Europe, there is no rainy season.
Yeah.
They have only hot and cold season.
Yeah.
So to decide hot and cold seasons, it is all right, you can use the tropical year. But our concern is, okay, the hot season is a sort of a nuisance, if you like, and cold season, all right, but the real season, the economically productive season, is the rainy season.
Yes.
And it's not just for human beings. The entire life in the region depends on the monsoon.
Yes.
Because that is a breeding season for all of life here. Because that's when food is plentiful, and that is where you have this. So the monsoon season is all important for all life in this region. And now the point is, how is the monsoon season to be decided? So monsoon season is not just decided by hot and cold.
Yeah.
Because if you just take heat, you look at the earth, the hot air rises at the equator because the equator gets hottest.
Yes.
And it descends. Where does it descend? It does not descend at the poles. Poles are the coldest. It goes part of the way and then it gets turned around because the Coriolis force. The earth is rotating.
Yes.
Right? So it gets twisted, and likewise the cold air coming gets twisted in the other way. And therefore you have the Horst latitudes where you have winds blowing this way and winds blowing that way. Point I am making is that if you are looking at the rainy season, our concern is with the wind regime, not with the heat regime.
Okay.
Because monsoon is decided by winds. Now the next point I would make is that this is I must admit I am very frustrated that I have been making this point for so many years and people just don't seem to understand it.
I see.
At that point, I made this point to the government, and my vice chancellor was advising the government, and nothing happened. And he was advisor to Digvijay Singh, not just the government, advisor to the chief minister. And so he should have got something done, but nothing happened.
I see.
And since then, this was 25 years ago, something like that, approximately, may not be 20, maybe 20 years ago. So the simple reason is that if you want to understand wind flow, we are talking about monsoon, we are not talking about random winds here and there. So we want to have a systematic driver for winds, systematic seasonal driver for winds. And so I am saying you have to take the lunar motion into account. Why? Because, you see, the lunar tidal forces are much stronger than the solar tidal forces.
Yes, indeed.
Almost twice as strong. Why is that? Because the tidal force varies as the inverse cube of the distance. It's the difference of two inverse square law forces. All right? So it goes as the inverse cube. And the sun is very massive, but it is very far.
Yes.
More than 8 light minutes, and moon is only about 4 light seconds. So it's very close. And so you have the tidal force of the moon much larger. Now, this tidal force, when we think of tides, we normally think of tides in the sea. And then we think, okay, how high has it gone, this much and so on. Now, this force, tidal force, is not about increase of height. Because, the tidal force is not so large as to counteract the gravitational attraction. So, the rise in the sea level will be very little. Why does the sea level rise? Because there is a flow. We are looking at the horizontal component of the tidal force. Horizontal component of the tidal force is unopposed. Vertical component is opposed.
Yeah.
This is unopposed, and therefore it results in a flow. And where the seawater is blocked at the shore, there you have tide. You don't have tides in the open sea.
Yeah.
Right? So you have tides here. Now the same thing applies to air. See, air, it will apply much more because seawater is about 1,000 times denser than air.
Yes.
Right? So you have a huge component parallel component which is driving wind, just systematically doing it. And this will have all kinds of cycles, including a cycle of Rahu and Ketu 19 years, because that also affects the tides in the sea. All right, that has been demonstrated. It will also affect the tides in the atmosphere.
Okay.
So, what I am saying is that if you are looking at the wind regime, which you should, because the economy even today is Indian economy is critically dependent on the monsoon.
Yes.
The monsoon fails, everything fails. Once upon a time, it was total disaster because it was totally dependent on agriculture.
Yes.
Now it may not be totally dependent, but still very heavily dependent. So, large part of their, labor force is still into agriculture, dependent on agriculture.
Yeah.
So, this is a very important thing which unfortunately Meghnad Saha, he muffed it.
Okay.
You know, he was colonized. He was an honest man and so on and so forth. He was a competent scientist, but he muffed it because he was colonized. And he said they decided for seasons, so we also should have seasons. And seasons were divided by the tropical year. That's what every book says. But it does not tell you how the wind regime is going to be decided by the tropical year. It is not going to be decided, right? So there the lunisolar motion becomes important.
The lunisolar motion.
Because after all, there can be combined lunar and solar tides,
yes,
and so on. There can be opposing tides and so on. Depends on the position. So if you have Amavasya, you have one type of tide, and you have Purnima, you have another. They are opposing or they are together. So it can be what are called neap tides and so on. Different types of tides. So, all these factors matter. You have to consider both. You have to take them into account. We have not taken them into account. We will not take them. Everything I can't do. I dump everything on. It's a very simple idea which should be followed up. Right? And anyway, maybe if I live long enough, I might do it. But the issue is just this, that we are not doing it. And this is so important for our economy. Just think of, there's a drought. And the drought can happen. It happened. I've documented those cases taken newspaper cuttings where the monsoon was, so to say, delayed.
Okay.
But delayed means what? Who said that it has to have a periodicity of the tropical year? It's just an assumption, right? Nobody has proved it.
Yes.
So it came on time according to the Indian calendar. There was an Adhik Sawan. It came on time.
Okay.
But it was delayed according to the Gregorian calendar. And so you said it's delayed monsoon, and this phenomena keeps happening. And although they were preparing for drought, there were floods.
Okay.
This happened, a huge flood. This was the time when Bombay, remember, there was a huge flood and all the cars got washed away.
I see.
Yeah. This was around 2004 or something like that.
Oh, the gigantic flood. Yes, of course. Oh, indeed.
So,
indeed.
They were expecting drought. There was the whole thing was so many crores was sanctioned for drought, but they will not sanction for study. So that money has to go to their own people only, right? So that is all controlled, and not for the benefit of the country as a whole. They don't think of that at all. That's a big problem. And so I think that this idea that the Indian calendar is scientific, and it's there are other things, For example, we always say Rahu and Ketu I talked of.
So what are Rahu and Ketu?
Rahu and Ketu are nodes of the moon.
Nodes of the moon.
Nodes of the moon. See, when you want to talk of an eclipse, so you do not have an eclipse every Amavasya or every Purnima. Why? Because the sun, moon and the earth must be in the same plane.
Indeed.
Right? So when will they be in the same plane? So if you look at the plane in which the sun goes around, the earth is seen to go around the earth. If you like, earth goes around the sun, the same thing. That is the ecliptic. And now the trajectory of the moon is not in the eclipse.
It is not.
When it crosses the ecliptic, goes down once and comes up once, those are the nodes of the moon.
Okay.
Those are Rahu and Ketu.
Okay.
Right? And they will also move and so on, various things will happen with them. And they are all described in the Indian text.
So people think of Rahu and Ketu as an astrological concept.
Well, that is, you see, now this is something one can't go into. There is a very scientific way of doing it the way Aryabhat will do it.
Okay.
So the way so many other astronomers will do it.
Yes.
All right. But that is not taken into account because always it is the superstitious angle which is talked of here.
Indeed, yes, that's what.
That is a polemic that is there. For everything, they'll talk of Rahu and Ketu. I have written on this scientific temper versus colonial temper.
Okay.
I call it colonial temper. I got irritated by some chap who was talking about Rahu and Ketu as superstitions.
Okay.
This guy is a physicist. He should know what they are.
Indeed, right.
Before talking about it, So yes, there are superstitions among the masses. That is true everywhere. I mean, after all, there are plenty of people in the US who believe. I mean, according to your what is that? The sample survey that is conducted.
Pew Research. Pew Research.
No, there's another one.
There are Gallup polls.
Gallup polls.
Okay,
That's right. Thank you very much. So the Gallup polls, they have right up to the 90s, you have very clear indication that there are so many people who literally believe in heaven and hell.
Okay.
Right? So they believe that they are literally there, and this is what's going to happen. So superstitions can coexist with science. So you won't say that US does not have science because there are superstitions there.
Yes, right.
So they can coexist. So we have to look at the scientific part.
Right.
The fact that there are superstitions doesn't really deter. I mean, it is like saying, let me take an example. Atlas. So Atlas was a Greek god or demigod or whatever who took the weight of the earth on his shoulder.
Yes.
That's a superstition. So how do you know the earth has weight? In fact, in Indian tradition, they say, why should the earth fall? Because which direction should it fall? Things fall towards the center of the earth.
Yeah.
Where will it fall? So the earth has no place to fall. So they are very nice scientific arguments. And then they say, if the earth is supported by something, then what is that supported by? If it is a Sheshnag or whatever, what is that supported by?
Yes.
So if that can be given the power to stand without support, why not give the same power to the earth? This is in Lalla, Shishyadhi Vriddhid. He has a 20th chapter on what is called Mithya Gyan Nirakaranam.
Okay.
Right? So there is mythical knowledge and so on and so forth that may exist, because not everybody is a scientist, not everybody may understand, they may be engaged in other professions. So he corrects it.
Okay.
But this is never talked about. There is no correction. Who corrected? Who laughed at Atlas? On the contrary, it's celebrated. In Rand will write, Atlas shrugged. This is something very great. The earth is taking. This guy shrugged. So it is something celebrated there, and here it is dismissed as superstition. Why not dismiss Atlas as superstition? So therefore, will you say that every geographic test that has an Atlas is superstitious? This is ridiculous, right?
Yes, it is.
So you have to see what is the context in which something is being stated. And this is being stated in an astronomical context. Rahu and Ketu, and very clear parameters being prescribed, and those parameters make perfectly good sense. So that is the thing. And now there may be, myths and legends and all sorts of things around that.
Indeed.
But that does not detract from the scientific nature of the thing. So Rahu and Ketu are there, and that led to a successful theory of eclipses, which they did not have. You see, in fact, on the contrary, we are talking of Easter. You see, Easter is celebrated near the full moon. Right? It is Sunday after the first full moon.
Okay.
What happens is that it is supposed to be a festival which celebrates the resurrection of Christ after his death on the cross.
Okay.
The Bakrid, and how it was symbolically interpreted that Christ was symbolically a lamb who was slaughtered on the cross to save others from sin. That is how it was symbolically reinterpreted.
Okay.
So Easter is about his resurrection, and there is this talk of darkness at noon, that God was annoyed and therefore there was darkness at noon. But how can there be a solar eclipse at Purnima or near Purnima? See, it is absurd, and this is there in the Bible. So nobody will ever talk of that this kind of a superstition, because they did not know how to predict eclipses. They did not have any idea what the earth is like or what the sun is like. They did not have any idea. And they had this kind of silly belief, but that is never talked about. But only in the Indian context, they will say, this guy said something like this. So that is how I think we need to look at. There is a very clear scientific understanding of Rahu and Ketu as nodes of the moon. And numerical parameters prescribed for how these nodes rotate and so on and so forth. So they move, like the planets move.
So how long has the Indian calendar existed? Do we know?
Well, what we do know, see, if we go by documents, the earliest document we have is the Vedanga Jyotish.
Okay.
Now, the Vedanga Jyotish is not a text on astrology. The word Jyotish does not mean astrology.
Okay.
In fact, when this Murli Manohar Joshi had introduced 16 university departments in astrology, Kapila Vatsyan organized a debate in India International Center. This was, I think, 2001.
Okay.
So I was there Raja Ramanna was there, and Pushpa Bhargava was there. 3 people from the side of the scientists. And astrologers were called. Should we be teaching astrology? So at that debate, I took out the Vedanga Jyotish. I said, here is the text. Show me one sentence on astrology. International press was there, everybody was there. And nobody knows about it. And our expert thing was, show us the book. They've never seen the book. What can you say?
Okay.
They've never seen the book, and they prescribed, they opened 16 university departments on Vedic astrology. When it's not there's not a single word of astrology, and not just the Vedanga Jyotish. If you see the entire astronomical tradition, from the Vedanga Jyotish to, let us say, Yukti Bhasha or Tantra Sangra, so on, then you have 3,000 years. Not a single word on astrology in any astronomical text, including that of Varahamihir.
Okay.
Even Varahamihir, if you look at his Panchasiddhantika, there's not a word of astrology there. Brihat Samhita, different matter.
So it's just astronomy.
It's just pure astronomy. I'm saying that this entire 3,000-year tradition, you do not have a single word of astrology. So Jyotish is timekeeping. That is the meaning. Kal Vidhan Shastra. That is what it is.
Okay.
That is how it is defined. And it's just misinterpreted, grossly misinterpreted. And now the point is, we collaborate with that misinterpretation. That is very sad. Why should we collaborate with that?
Right.
So this was purely scientific. Now from that point of view, we can fairly clearly date the Vedanga Jyotish to approximately minus 1500 CE, where CE I mean Christian era.
Okay.
Use the Christian era, but call it Christian era.
Yes.
That's all that I don't say it's common. Right? So, or to minus 2000 CE.
So minus 2000 CE, we had a fully formed science of astronomy, and we had the calendar.
Yeah, but that's a different calendar. It is, it's a sidereal year, it's a sidereal day, and so on and so forth. It's a different year, and the Yug is not the Yug of the Surya Siddhant, it's not the Yug of the Puran, it is a 5-year cycle, and so on and so forth. It's a different calendar. Okay, so, but it is a scientific thing altogether. Okay, so because you have the nakshatras. Because 27 nakshatra means you are looking at the sidereal month, and that is 27.3 days. And so the moon moves through one nakshatra in one day, approximately.
So it was a fairly good and scientific calendar. Around 2000.
It was not, it could be made more accurate, it was made more accurate, but it was a scientific thing totally.
So to construct a calendar like that, it takes centuries of astronomical observations.
I don't know, because nobody else did it. See, nakshatra is unique. It's unique to the Indian tradition. So you have the Rashi, you have the constellations which are there everywhere. But nakshatra is unique to Indian tradition. Those 27 nakshatra are unique here. Nobody else studied the motion of the moon, and nobody else had a synodic month. They did not know how to study the moon. So,
but that predates the Aryan invasion, doesn't it?
There is no Aryan invasion. There is no Aryan invasion. You've seen my book on the Aryan race conjecture, so there's obviously no Aryan, because the Aryans could not have done that. Maybe we'll take that up in the next part about the arithmetic, why the calendar was so bad, and look at that. And so I think that we need to understand these two things very clearly, that the Western calendar which we use is not a secular calendar, it is a Christian calendar, it's the Roman Christian calendar. The Indian calendar was a scientific calendar. Of course, it was subject to improvement. All science is subject to improvement at all times. Right? There is no question about it. But it was a scientific calendar. It was based on observation. It was based on theorizing, and the theories kept on improving, being corrected. And we should adopt it like that, and not engage in this kind of polemic of, all the time saying it is inferior, because this was a central polemic of Christianity, the central polemic of the church, and of colonialism. We are superior, you are inferior, imitate us.
So what should ideally happen? The government, should it adopt the Indian calendar, and would it be phased into existence? How would it happen?
No, one of the things you would need to do is to relate it to the monsoon.
To the monsoon.
To the rainy season, because that rainy season is unique to India, and it is valuable. If it is unique, does not mean we should not study it. That you have to have something which is global. Right? So if it is unique to India, we should do that, and certainly the government should do that. Now, what the government has done with the Calendar Reform Committee and so on is that you have some sort of a calendar, and they are looking at things like Vikram Samvat and Shak Samvat. Why not look at the Kaliya Hargan? The Ahargan is a very scientific concept.
Okay.
Ahargan is the number of civil days which have elapsed since a given era.
Okay.
So, Kali Ahargan is the number of civil days that have elapsed from the time of the Kali Yuga.
Okay.
So, what I am teaching now, what I am proposing to teach now to children is that first calendar you teach is the Kali Ahargan.
Okay.
So, you're counting just a simple count of days, and that is called the Julian day number system.
Yeah, indeed. Yes.
After Julius Caligula, who got it from India, obviously, and then just Christianized it a bit. And that is now used by NASA, because for everything they will use Julian day number, right? For all scientific things, because how do you do it in space? So, it is, we need to understand the scientific aspects of it. We need to celebrate our scientific achievements, and we need to understand that, it is does not help to call it Hindu, it marginalizes it. Hindu means only relevant to Hindus. It's not relevant to everybody, because if you're talking about monsoons, it's relevant to everybody, whosoever is living in this area. Right? So, I think that is very important. It's a scientific thing. And we need to discard the religious calendar and all the superstitions that come with it, the Roman Christian calendar.
Would the rest of the world also benefit from adopting the Indian calendar?
Well, not necessarily. I mean, it would depend, of course, because the monsoon is a unique phenomenon
To the subcontinent.
to this part of the world.
Uh-huh.
You don't have a monsoon there, so maybe it won't make so much difference there.
There, okay.
But certainly it would benefit in that it would throw out these superstitious beliefs. If you have a scientific calendar, why have these nonsensical months of varying durations and so on?
Yes.
So if you have a proper scientific calendar where the year is, if you want to use the tropical year, use a tropical year which gives you the precise duration of the tropical year, and not this kind of traditional thing that was done by Romans and Christians.
Indeed, indeed.
Right? So definitely they would benefit by discarding superstitions. But we don't talk about it. We are afraid to say the West was superstitious. And very obviously it was dominated by the church. It had to be superstitious because the church ruled with the help of superstitions. What is great about it? I mean, just see how many centuries it was dominated by the church.
Yes.
And so they had to have, there's a huge amount of superstitions there. Superstitions and myths and so on, which are lies and things like that, which is very much part of their tradition.
So even arithmetic is influenced by Christianity.
Yes. As a matter of fact, what I would say is that the Roman Christian calendar is so bad just because Roman Christian arithmetic was so bad.
Okay, okay.
So, let's take a look at it. The Greek and Roman arithmetic, it was, I'm writing a book on that, by the way.
Okay.
I'm writing a book on that, which I hope will come out shortly. It is called A Funny History of Arithmetic.
Okay.
And it is about Western blunders in learning basic Indian arithmetic, 10th century to 19th century.
Okay.
So, prior to the 10th century, what they had was early Greek and Roman arithmetic. And this arithmetic was very bad. It was very bad for many reasons. One of the reasons was that they did not have large numbers.
Okay.
So, the the Greek and Roman system stopped at a myriad. They could not count beyond a myriad.
Okay.
Now, myriad, even today, in the English language, it connotes infinity.
Infinity.
Myriad stars,
Yes.
myriad minded, myriad this and so on. So, that's the connotation in the OED. So, I have a lot of quotations from that. They are there also in my Aryan race conjecture book, that if there was an Aryan race, how come they were backward in arithmetic? They could not count. So they did not have large numbers. That is because they were using pebble arithmetic.
Pebble arithmetic.
Yeah. See, the word calculus for them did not mean the calculus we do today. It meant these little stones which were used for calculation.
Okay.
The word means gravel.
Okay.
So, for example, today if you have a stone in your gallbladder or something, it would be called a calculus.
Indeed it is, yes.
Right?
Yes.
Because it's a small piece of stone. So, that's what is called a calculus.
Okay.
And likewise in Greek, it is sepoi. So, a bit difficult for me to pronounce. Sepoi.
Okay.
So it means the same thing, pebbles, and they had Greek had pebble arithmetic, and early Greeks had only pebble arithmetic.
Okay.
So how do we know? We know that in fact they learnt this pebble arithmetic from the Persians.
Okay.
There is a vas. It's called the Dara vas or Darius vas, which depicts the Greeks paying taxes to the Persian ruler.
Okay.
And there, when they are paying taxes, because the taxes have to be counted, so they are using pebbles and a counting board, an abacus.
Okay.
So this was the system. And if you look at the system of numeration in Roman or Greek, it is totally adapted to the abacus.
Okay.
It is a system of coins and counters. So if you have I is just 1, V is 5, it's a coin of 5. X is 10, and L is 50, and C is 100, and M, if it is used, is 1000.
Yeah.
And so they are just coins. And then you can't have very large number. How will you collect 10,000 pebbles? Because a very large number of pebbles.
Yes.
And the other part, now the most important part is that, well, of course, they got it from, they got their good arithmetic from India eventually. But that was after the 10th century, because they got it from the Arabs.
Yes.
The Arabs were obviously wealthier. And they were, Spain and Portugal and Africa, those were the richest parts of Europe, which were dominated by, which were ruled by Muslims.
Yes.
So Christian Europe was very poor in comparison. And we find that the Pope, Gerbert, he later became Pope Sylvester II.
Okay.
They used to go to Spain they were still diplomatic relations prior to the Crusades. And so they used to travel, and Cordoba was in Spain, was a very prominent center of learning.
Okay.
Now, this chap was interested, Gerbert was interested in arithmetic, and he was considered to be very good at it, and he wrote a whole textbook on the abacus.
Okay.
The abacus is what is used, because you have so many coins, and then when you want to add, you pull together the coins, you simplify, and you can, one big 5 will be converted to 5 small ones, and so on and so forth. That's what you will do. Or 5 small ones will be converted to 1 5, whichever way. 5 and 5 will be converted to 1 coin of 10, and so on and so forth. That's how addition, etc. is done. So they knew only this arithmetic. Now, one critical aspect of this arithmetic which is useful for the calendar is the fraction. Because whatever year you take, whether you take the sidereal year, whether you take the tropical year, or whatever you take, you have to have a fraction. And they didn't have fractions. And that is what, as I said, if you look at the Egyptians had fractions.
Okay.
Egyptians had unit fractions. And there's a very famous fraction you have, the Eye of Horus fraction.
Okay.
And it's a very beautiful fraction. And it's a geometric series of fractions. And they had only unit fractions, but they understood fractions. But the Romans did not understand fractions. And as I said, the Romans got their calendar from Egyptians. This is a theory that I have, that it is not that the invader passes on knowledge. So there are 2 types of invasions. So this was a barbarian invasion. Egypt was a very old civilization.
Yes.
So barbarians can invade and they can conquer.
Yes.
But then they get knowledge.
Yes.
Right? So this is a barbarian invasion, like Hulegu, when he conquered Baghdad, it was a barbarian invasion.
Yes.
And Islam went to the other side and knowledge went to the other side. So in this kind of a barbarian invasion, you have knowledge flowing to the other side. Like the British, they came to India, they were barbarians and they took knowledge from us.
Yes.
All right? So this is what happened with the Romans. The Roman conquest of Egypt, they got knowledge from the Egyptians, and this was one of the knowledge that they got, which was the knowledge of the calendar. So Egyptians knew about fractions, and they said the year is 365 and 1/4, but they could not say 1/4 because the Roman didn't know how to write 1/4. They had some names for it, presumably, because they would have names for parts of coins. But they did not understand what is meant by 1/4 of a day.
Mm.
And so they told them to go with a system of leap years, which does not involve fractions, only involves every 4th year you add an extra year.
Right.
So it's still working with pure integer arithmetic, no fractions.
Mm.
Now, let's maybe go to the story of what happened with Gerbert and Fibonacci, and I think
Okay.
you will see a very critical point there.
Mm-hmm.
Gerbert, he understood something about the place value system.
Okay.
So he understood that there are no large numbers in Roman arithmetic,
Mm.
and you can have large numbers if you use a place value system. So he made what are called apaises.
Okay.
What are apaises? They are pebbles with the number written there.
Okay.
So instead of putting 7 of them, you put one pebble with 7 written on it.
Simplification.
Right. So that is one thing that he did with Arabic. That's the first Arabic numerals that came.
Okay.
Because they used the 9 Indian symbols, as they called.
Mm.
So for 0, they used nothing.
Mm.
Now, you have this kind of situation, but he did not understand, because basically Indian arithmetic is very efficient.
Mm.
See, if you want to add 2 numbers, it takes a large number of operations. I've given an example. Let us say 89 plus 89 you do.
Mhm.
Forget about multiplication, just addition.
Uh-huh.
So you will have to write out 89 in full form. So you will say V, then you will say X, 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 then you will say, I'm sorry, L, X, 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 then V, then I, four
Yeah.
I's. So it's horribly long.
Yes.
Already you have so many symbols. It's a very inefficient way of doing things. And then you will add and simplify. So it takes a large number of operations.
Mhm.
Whereas if you just want to add 89 plus 89 on the algorithm system, it is just a few operations,
Yes.
right?
Mhm.
So it's an inefficient system, takes a lot more time. Even writing numbers big numbers takes time. So Gerbert understood that you can use it to write big numbers.
Mm.
But he did not understand the efficiency.
Mhm.
So he made a foolish mistake by constructing an abacus, by constructing apaises.
Uh-huh.
Because abacus destroys the efficiency of algorithmic addition, which we learn in school.
Uh-huh.
89 right below it, and then add 9 and 9 plus 9 and so on and so forth.
Yeah.
So that's a very efficient system.
Mhm.
He did not understand.
Mm.
2 centuries later, see, this is 10th century we are talking about.
Okay.
So by that time, everybody knew so much. But the Roman Christian arithmetic was backward.
Mhm.
And so now you find that you have Fibonacci.
Mhm.
Fibonacci is a trader. He's a Florentine trader. And Florentines are, why is it such a big center for art and culture? Because they were the richest people at that time.
Right.
Why were they rich? Because they were trading with the Muslim world, which was the richest part of the Europe at that point of time, or with the Muslims in Africa.
Mhm.
So they were the richest people.
Mm.
Now, Fibonacci grew up in Africa.
Mhm.
And he learnt Indian arithmetic
Mhm.
from his Muslim teachers. He learnt in Algeria.
Mhm.
So he calls it Indian arithmetic. He calls it Indian symbols, 9 Indian symbols and so on. He doesn't call it Arabic numerals.
Mm.
Gerbert called it Arabic numerals as a different thing.
Mm.
He doesn't call it. He calls it Indian symbols. But see, he has 2 problems. He understood a bit about fractions. It's simplified form. What he writes in his Liber Abaci, it's a dumbed down version, I would say, of Mahavir's Ganit Star Sangrah.
I see. Okay.
It's a dumbed down version.
Mhm.
So why dumbed down? You don't have permutations and combinations. And then you say square roots, cube roots, very difficult to do. So they are postponed to a later chapter. He won't have, many things he won't have.
Mhm.
So he's only interested in the commercial applications. Mahavir is the closest to that, because Mahavir is a Jain,
Okay.
right? So he, as you know, Jains are involved in trading, and so he is interested in commercial applications. He mentions other applications, music and so on, where permutations and combinations are important. The entire Indian theory of music is based on permutations and combinations.
Yes.
Right?
Yes.
So binomial expansion and so on, meter,
Yes.
binomial expansion is there and so on. So he's not really a mathematician. And Fibonacci numbers are also taken from India. Right? This is, but we are straying from that topic. So what happens with Fibonacci? One important thing happens, that he doesn't have negative numbers.
Okay.
Why? Because in pebble arithmetic, what is subtraction? You take away from what heap of pebbles you have got. So that is subtraction. So you can't take away more than are already there. So he has a chapter in Liber Abaci which will say you have to subtract a smaller number from a greater number. That's a chapter heading.
Okay.
Whereas in Mahavir's Ganit Sar Sangrah, he will say about general observations or general rules about zero, common rules about zero, samanya niyam, no? So you'll have common rules about zero, positive and negative.
Okay.
Which he does not have. And this is exactly what you have in the calendar. They won't have any negative days. Why do you have AD and BC? Because you want to say everything in terms of positive integers. Very simple thing would be to have 0 and then you have a continuity. You don't have to leap 1 year. No, after 1 you do not have -1. You have 1 BC, which is you can't. It's confusing. So you should actually have a proper system with negative numbers. Why don't you have negative dates? You should have. I use them. Right? So that's the right way. Why should we use BC?
Yes.
Even if you are using common era or whatever, put it as my negative numbers.
-20 or whatever, yes.
So they don't have negative numbers in the calendar.
Yes.
And that is very clearly because they are missing negative numbers in Roman Christian arithmetic. They are missing them at the time of Fibonacci. They are missing them at the time of Fibonacci because Fibonacci takes some Al-Khwarizmi and they are missing in Al-Khwarizmi. Some Arabic sources, and I know only one, have negative numbers. But Al-Khwarizmi doesn't have them. He took it from Al-Khwarizmi.
Okay, he took it from there.
He took it from there. So there are no negative numbers. And therefore your calendar always AD or BC or whatever, it is B something. Why before so many days? Why not simply negative? You don't have. So that's a characteristic of Roman Christian arithmetic, which reflects in the Roman Christian calendar. Then the other part, of course, as we saw, that because Romans did not have fractions, the Egyptians gave them a leap year system which works only with integers. And now these fractions of Fibonacci comes in the 13th century. And by the 16th century, the Jesuits are here and so on and so forth. And they understand this system, and then they have taken it to Europe again and again. I mean, apart from Fibonacci, there are many other people who wrote. I mean, but they always think of it as on the Indian system of pebble pushing or something like that, they will say. Because they can't get beyond the pebble arithmetic part.
Okay.
Right? And so they're still thinking in terms of pebbles. And therefore, they can't easily manage fractions. Because supposing I want to say tropical year is 365.242 days. So that decimal fraction, so let us convert it to an ordinary fraction. So 242 by 1000. So what will I do? I'll take a pebble, divide it into 1000 parts and then try to
Okay.
Right? So you won't be able to count so many. It will be a big problem. So because they were thinking in terms of pebble arithmetic, they could not do that. And therefore they had this complicated system that every 4th year is a leap year, but every 100th year is not. So it becomes 25 minus 1 by 100. But every 1000th year is. So it becomes plus 1 by 1000. So it becomes 241.
Okay.
Correct figure is 242. That
Okay.
figure they got from India, by the way.
Okay.
Yeah, so that's a separate issue. But they did not have fractions, and therefore their calendar was bad. Therefore their reformed calendar was also bad. But by that time they did have fractions. Clavius had introduced, Clavius was the author. Gregory just had the name. Christoph Clavius was the actual author of the Gregorian reform, and he had introduced fractions into the European syllabus as practical mathematics.
Okay.
Right, because they had a spiritual mathematics starting from the time of Plato.
Okay.
And this was practical mathematics, good for commercial purposes and so on and so forth, and for other practical purposes like navigation and stuff like that. So he had introduced practical mathematics, which had fractions, I mean, basically taken from Indian texts directly from Kochi.
Okay.
Right? So it went in various forms. So first time it went from Cordoba to Gerbert. Second time it went from Africa via Fibonacci. And third time it went direct from India. So many times Indian arithmetic went there, but they had big problems in reconciling it with their pebble arithmetic. So the correct word for Roman Christian arithmetic would be pebble arithmetic. So we can say Roman Christian pebble arithmetic. And because their arithmetic system was so poor, and because it was so persistently poor, they had problems with deciding the exact duration of the tropical year, of stating it. And they had problems with negative numbers. The problems with negative numbers persisted right until the 19th century. They had many problems with negative numbers. See, they boast so much, we did this, we did that. Now, the point that I'm making, one of the important points is that if the Romans or Greeks had any science, they should have good arithmetic.
Indeed.
If they did not have good arithmetic, how could they have science? And here is the proof. Look at the calendar. The Greek calendar is so horrible. The word for Greek calends is, it is what is called, it is humorous for never. Why? Because what is the calend? Calend was announced. So, first day of the month. And the speciality of announcing it was that debts had to be settled on that day.
I see.
So, the Greeks had no calendar, so you never settled your debts. Wait till the Greek calends, it was that kind of thing.
I see.
So, they did not have any system of asserting it, either religious assertion or authoritative assertion, state assertion, as Romans did. So, they had no calendar. The point is, till today you can see, if they were so good at mathematics, they were so good at astronomy, as people would say it, if there was this Ptolemy chap, Ptolemy not the king, Ptolemy king of course was there,
of course.
They were there.
Ptolemy,
Claudius Ptolemy, the astronomer. Then they should have had a better calendar, right? But they don't have. So, because they have taken very late texts, have taken now fractions. Yeah, maybe we should look at these fractions in early Greek times. You see, we are talking about late Greek texts. They are Byzantine Greek texts.
Okay.
Now, Byzantine Greek texts are basically from Turkey. And they are, obviously, when all this Indian system has gone to Arabs, it has also gone to Turkey.
Yes.
Right? There is no question about it. Now, one of the systems of fractions which was used in India, sexagesimal fractions.
Okay.
See, they will say that Greeks got their sexagesimal fractions from Babylon.
Okay.
Babylon had sexagesimal system, I am not denying it. But what is the evidence that Greeks got it from there? What we know is that Byzantine Greeks used it, that is in the mid-19th century or later. Now, by that time the script has changed, it is minuscule script. So, early Greek was all capital letters. Now, it's minuscule script where you have a cursive script and so on. So, it is completely different script, it's a completely different land, and it's a completely different system of fractions. Now, in India, you have sexagesimal fractions for timekeeping. For everything you have, and you have a proper sexagesimal. See, because you have 24 hours in a day,
yes.
But every day, every hour is divided into 60 minutes, is divided into 60 seconds.
Yes.
So, it's not a proper sexagesimal system, it is a partial sexagesimal system. But in India, you have fully sexagesimal system. All right. So, you have Muhurt is a very common thing, and you have Pal and Vipal and so on and so forth. So, it's a fully sexagesimal system. And you will have 60 ghatis. 60 ghatis and 60 pulse and 60 vipals and so on.
Okay.
So, each ghati is 24 minutes.
Okay.
Right? So, it's a fully sexagesimal system. And this is a very ancient sexagesimal system going back to Vedanga Jyotish.
Okay.
Right? So, you have a sexagesimal system. You know that Indian astronomy went there. You know that Indian astronomy kept using it. You know that Arabs had great difficulty with it, because if you want to do sexagesimal arithmetic, unlike decimal arithmetic, you have to have tables up to 59. Right? That's a big thing. And so they talked about the problem of multiplication. And Ptolemy does exactly that, because the text you have is 12th century. Why do you say it is not affected? What were those people doing? Just copying blindly, not taking care of whatever is happening recently? That is nonsense. So it is a myth, and they just added on a thing about getting it from Babylon. There is no evidence that they got it from Babylon. And there is evidence that Byzantine Greek texts were influenced by Arabic texts, of course, heavily influenced, and that Indian arithmetic, sexagesimal arithmetic, went there. So, timekeeping, even in terms of hours and days and so on, that went in, not hours, I mean, hour becomes hora. But
Hora.
But sexagesimal arithmetic, sexagesimal fractions went from India. And now Ptolemy will use, not just thirds, fourth, fifth, sixth, such precise fractions. He does not have even the duration of the tropical year correct. What is the sense in such huge precision, theoretical precision, when you don't have simple observation to fit that precision?
Okay.
So, this is all a whole lot of ocean of lies which has been told to us about this achievement. And what this shows, the shoddy calendar shows that shoddy arithmetic led to shoddy science.
Mm.
And this is non-textual evidence very clearly in front of us. Why should we bother about what these texts say? Then you have to learn Greek, you have to go there. And it's such an expensive thing. Just going to Rome and looking at the Vatican archives or Jesuit archives, it's such a lot of money. You go with a translator who will come, and then you stay there, and then you go through slowly. It takes a huge amount of expense.
Mm-hmm.
And they won't give you.
They won't give you access.
They won't give you the full access.
Mm.
Vatican, okay. Jesuit archives are still secret.
Mm-hmm.
So they have a secret chamber in which everything is locked up, not to be given to others.
I see.
Yeah. So they won't give you the stuff. I got some of the stuff, but that is all which is available, which is published already. Not something which they keep secret.
Okay.
So this is all very difficult. Therefore, non-textual evidence is very robust. And we go by the non-textual evidence of the shoddy calendar. That is why it is so important that it completely busts the myth of Greeks having done something. The Greeks did something, suddenly there was a dark age. It's like Cinderella, coming with the carriage, and then suddenly it turns into a pumpkin or something like that. It just vanished. What is this knowledge came, just vanished? Where did it go? So it is just nonsense to talk of this kind of a dark age where suddenly it disappears. And the fact is that the Greek calendar was always bad. There is no sign of a good Greek calendar. And there is no sign of a good Roman calendar. And then it was adopted as the Christian calendar, and it has persisted down to present times. And you look at it and see how bad it is. So that is very important. That it was bad. It was bad because the arithmetic was bad. The arithmetic was bad because it was Pebble arithmetic. And they stuck to that. They stuck to that till very late in life. You see, even the exchequer, the whole idea is exchequer is the checkered board on which calculations were done. But state accounts were maintained on that. That was introduced by the French. And they kept following that, and it was only after they would say sometime like middle 19th century, middle 19th century or maybe early 19th century, that they started getting rid of this Pebble arithmetic.
But they still have the Chancellor of the Exchequer.
They still have Chancellor of the Exchequer. He's the
Finance
Minister.
Yeah.
Right? He's the Finance Minister.
Yes.
In Britain. So they have that terminology, Chancellor of the Exchequer.
Yes.
And but they gave up that Exchequer system, and it went out with a very big bang, actually speaking, because they used to use these, they used to write it up on what Charles Dickens called Robinson Crusoe arithmetic. They had tally sticks. They had tally sticks on which they wrote this.
Okay.
And then they kept all the accounts, and they kept it there because it was Exchequer, so it was kept in the House of Parliament. Then they said, now we want to get rid of it. So how to get rid of it? As Charles Dickens says, there's so many poor people, just give them the sticks and they will burn it and they will keep warm in the cold winter. So he said, no, it is top secret, so it has to be burnt right here.
Okay.
So they burnt it in the Parliament, and the whole British Parliament burned down. So that is the story of the Great Fire. And so much money was spent on reconstructing the Parliament building.
Yeah.
And so that is the farcical end of Roman Christian arithmetic. The tally sticks burned down. Right? And of course, there are so many mistakes. We call all these people great. Look at Euler. So Euler gets confused about negative numbers. The great Euler.
Leonard Euler.
Huh?
Yeah. Leonard Euler, right?
Yeah, Leonard Euler. So he gets confused. So he says, along with John Wallis, see, you have -1, less than 0, less than 1. Now you take reciprocals. So therefore you'll have 1 by 1 less than 1 by 0, which he calls infinity, must be less than 1 by -1, which is -1. So infinity is less than -1. So -1 is less than 0, but greater than infinity. All sorts of foolish things they did. And we don't understand, we don't recognize, we just learned one lesson that they taught us, that West is superior. Don't look at the facts. And so I think it's important to look at the facts of arithmetic just to see how inferior the West was, even in terms of elementary arithmetic. You see, about calculus, when I start explaining, real numbers are not there. They did not understand. Newton did not understand. Most people don't understand what I'm saying. Even if they understand a bit, they are not willing to accept it. Arey, kuch to hoga. Humko nahi aata hai to kya hoga? Now, I am an expert in that. I taught formal mathematics. I taught real analysis. I did functional analysis. I taught it for so many years. So I understand what I'm talking about, but most people don't know. So who is this chap saying, we don't know what is true, what is not true, and the mathematicians won't debate. So there is a big problem. But arithmetic and calendar, they are very central issues because they are very easy to explain. The reason why I took this up, it's easy to explain that what you think is superior is actually inferior, and that the evidence is in front of your eyes. So that is why I took that up, and this is also the case with arithmetic, that okay, you talk about calculus, people don't understand what real numbers are. What is this challenge that I am giving, that prove 1 plus 1 equal to 2 in real numbers, and offering 10 lakh rupees, it's still there, right? But the simple thing is that for arithmetic at least they should understand that not only it went from India, but that they were such terrible fools that they, from 10th century to 19th century, they did not understand the basic principles of Indian arithmetic. They got confused about zero, they got confused about, there's the Florentine law against zero, they did not understand place value, they did not understand negative numbers, they had problems with large numbers, and they continued even into the 20th century.
Got it.
So I think this is very important, that bad mathematics, bad arithmetic leads to bad science. Calendar is an example of that, and bad arithmetic was there. It was taken from, arithmetic was taken from India, and they could not understand. Now you can say, was it due to genetic reasons? Was it due to was it racially inferior? Whatever. I don't want to say that. I'm just saying it was the paradigm of Roman Christian pebble arithmetic, which they had, which they could not get rid of.
Got it. Well, sir, thank you so much for a wonderful exposition of all these issues, the calendar, the mathematics, arithmetic, all that. Really appreciate that.